Welcome everyone. So today we are going to do lead code contest 176. Hope you guys got a chance to look at the problems ahead of time. If not, then I will try to explain, but not sure it will make that much sense. But I will try my best. So here is the problems. Like there are 4 problems. First is kind of easy. Second is medium. Third is medium. Fourth is hard. So we'll start with the medium of actually it's easy problem. So you guys can see my screen, right? Can anybody confirm?
Yes, we can.
Great. So in this problem, you are given a negative numbers in sorted matrix. So the matrix is sorted both row wise as well as column wise, and you have to return the number of negative numbers in that grid. And the bound is that both rows and column is maximum 100, and the values are also 100 maximum, either in minus or plus. So what approach can we do? I will try to explain on the board as well. In the meantime, you can think about what you will do. So here is let me try to write something. 4, 3, 2, minus 1, then 3, 2, 1, minus 1, 1, 1, minus 1, minus 2, and then minus 1, minus 1, minus 2, minus 3. So in this particular example, the count will be, this one is like minus 4 here, minus 2 here, minus 1 here, 1 here. So 1, 2, 2, 4, plus 8.
So each row is sorted in the non-increasing order. That's correct?
Yes,
Okay.
increasing order. So you have this way sorting done. If you look at this way, you have the sorting done this way too.
Okay.
In
So
decreasing order.
Okay,
Both.
makes sense. So both rows and columns are sorted in non-increasing order.
Right. And you have to count negative numbers.
And the top left is the biggest one, the largest element. The bottom right is the smallest element.
Yeah, you can say that. This is max. Yes, this is max. And this is min.
So because it's already sorted, so I'm thinking I'm starting from the top right most element. So if it's negative, let's say right now it's negative, then I move to the left.
Okay.
Okay. And now it's positive. That means whatever on the left will be positive. Then I move down.
Where you are starting from?
I start from the top right most element.
Oh, from here you are starting.
Yes.
Okay.
And then because it's negative, so I move the iterator to the left.
Okay. So from here, where you are looking at,
I look at the element right here. It's negative.
Okay. So this was negative. So you counted 1, and then what did you do? Did you go left or?
I moved to the left.
You moved to the left.
Yeah.
Why didn't you move to the bottom?
Because there could be a negative element on the left. So I want to move to the left to find all the negative element on the same row first.
So, okay, if I cover this one, suppose now I see that it's not negative, then what do I do?
Then now I move down.
Okay.
Okay.
No, I believe from -1.
Yeah, but he moved from -1 to 2.
Yeah.
So are you pointing to both the places,
No,
or
only one element. I point only one cell at a time.
so you are
So
pointing here, right?
yeah,
Currently.
when I move down, then I begin to accumulate the negative number of elements on that row. So in this case, the first row, when I'm moving down, that means I count one negative.
So, okay, tell me, when you reached here, what decision you will make? Like from 2, did you reach 1, this one?
Yeah.
So what will you do here?
And then because it is positive, then that means whatever on the right of that also have to be negative.
Okay.
Because the reason I think is because the element is sorted in this case in non-increasing order in top down.
Okay. So, okay, it's good. Hold on to that thought. We will come to similar approach very soon.
So since the matrix is sorted, so we can sort only use to compare the first all elements until we will first get the negative, right? And then return the length of the rest. Is that correct?
Was that a question or a statement?
I mean, I'm trying to say since the matrix is sorted, so what we can do, we can sort only use to compare the first all element until we meet the first negative.
Okay.
And then return the length of the rest. Yeah.
Okay. So, all right. Let's go through a couple of things. I think we are all talking about the same thing. If you are given, and suppose you were in the contest, we'll take it when we are not in the contest also, but you were giving that m is 100 and n is equal to 100, then do you think like brute force approach that go and check all the values will work?
Yes.
Okay, that's good. So that way we know that m into n approach will definitely work. So probably if you were in the context, you will do that and you can move forward, right? It's okay.
Yeah, because the m and n are small. Yeah.
Yeah, quite a small. You can do that. A better brute force approach, because in this particular case, we are not even looking at like whether a number was negative or not. Maybe like somebody said that this was minus, this was the smallest guy, right? Suppose this was already like, this was not negative, it was 100, for example. So if you start your brute force approach from here in this way, like, start checking, then as soon as you see something is positive or non-negative, like even 0, then you can just terminate your check. You don't have to do like all the elements, you don't have to visit. It depends on which kind of input you got, right? So in that particular case, maybe you will see all these elements, then from here you will see this much. So what you are making conclusion here that okay, next time if I go to the above row, I don't have to check anything after this, like after these 2 elements. So 2 is my maximum leftmost direction where I have to make a check, because that anything after that will be positive, because the order it was given in is helping you. So here you will check this one, and then you will check here. Your boundary is now moving towards this one, that hey, just look at one element on top. So this guy will just look at one element, and you have this way calculated everything without visiting all these elements.
True. Yeah, it's better.
So it's a brute force, but better brute force, right? But worst case complexity is same. There is a question. Can somebody tell me what the question is? I can't see. The base problem for this can be searching in a 2D sorter. Yeah, we will come to that, Puneet, very soon. All right. So now we haven't used yet that these guys are sorted yet. So one approach somebody, I think, maybe suggested or not, could be that, okay, I know this row is sorted. This row is sorted. this row is sorted and this row is sorted, right? Maybe I will, since it is a sorted array, let me search where can I insert a -1, like, do the binary search on an, like, any row. So suppose there are m rows and n columns. So for each row, do a binary search, check where can I insert a -1. That could be done in whatever is the element, like if there are n columns, then log n time, right? And if we do that for m rows, we can get m log n, right?
Yep.
Any question?
Yeah,
Any question on that approach? Because we are just using that property of sortedness here. Okay, not. The other way you could have done that, instead of going that way, you start column wise, because this guy is also sorted, right? So you, instead of going row wise, you can start doing column wise. So in this case, your complexity could be n dot log m. Yep, there is another chat. Either somebody can talk or
okay. So
can
if
read.
you do column wise, you still do the binary search, right?
Yeah, well, let me. What do you mean
Hi
partial
Roger.
rows? What?
The partial rows means like say for the row 1 is sorted, row 2 is sorted, but row 3 is not sorted and row 4 is sorted.
Yeah, but all the rows are sorted here, right? As per the problem.
And the column too. Column are sorted
Yeah,
too.
both are sorted. Like look at the problem, like they both are sorted.
Okay.
So what I am suggesting here, we have a better approach. We know we will come to that at last, but suppose in this particular case, you are getting m log n. You can also get n log m if you do column wise sorting. So if your structure is like this, for example, this, where you have these many things versus you can have a structure like this, you can make sure that wherever you are applying the log, choose that to be bigger. If m is big, then I would prefer to have n log m. If n is big, then I would prefer to have m log n. Does that make sense?
Yes.
Because idea is same, but now you are also looking at, okay, where to apply what to make it faster. Same idea, but only thing is now I will check, hey, if I have more columns, let me apply log there, versus more rows, let me apply log search there, like binary search. And that way we can get a better time complexity. So that's another approach. And here what we did, we applied that one of the truth that this is sorted or this guy is sorted. So we are given two truths, like two things, that this is sorted this way and this way, but we are choosing either one of them, right? Either this or this, and we got a better time complexity. So now what we are trying to do, that can we apply both? Like, can we apply this truth that, hey, both are sorted? So that is the approach which we started with, and now we can talk about that. And that is the, like, it's good for your interviews, and we have seen maybe more problems like that. So let me try to erase, and if anybody has any questions in the meantime, feel free.
Yeah, like in the binary search, you are looking for where to insert -1,
Yeah.
right? So what if it is all, I mean, it contain -1 already, where the position will tell us like how many positive. For example, this 4, 3, -1, -1.
4, 3, -1, -1. Okay. So is it possible to find the leftmost -1 or rightmost -1 using binary search? That is your question, right?
Yeah. Yeah.
So do you think it is possible or not?
Mhm.
I
Yeah,
mean,
then we have to check that it should be at least the leftmost, because then only positive will be counted. I mean, negative can be counted. Yeah, got your point.
yeah, so that's a question in itself, but it is very
Yeah.
like trivial to
Yeah.
do that.
Yeah.
So
Got it.
let's move that. No, it's fine. I like questions. That's good. So here, if you look at this structure a little bit, like we will have something like this. Not exactly, but kind of like this, because we know. So something like maybe something like this. I don't know. Now these guys are the minimum here. We are decreasing value here. We are decreasing value here, and I'm asking you a question, like without like going through this. Suppose this is a like swimming pool, for example. These are the lanes of the swimming pool, and you have been asked to check the like area of that, right? How would you go about doing that? You know that the lane's depth will increase as you move either in this direction or in this direction. Where would you start from? I mean, it's the same problem. Like I'm just making it a like real world problem.
You can start from either one, right?
So you can start either end, right?
Yeah.
If you dip your toe here and you see water, then you already know that hey, there is no need to go to this lane because I know everything in this lane is already filled with water, actually with more depth, right? Anywhere you start, you just check this one. You already, if it is a water, you know that I don't have to calculate going down because I know the lane's depth is going to increase. That means everything from here till here is water. So what you will do, you will say, okay, I know the current like area. My area could be, suppose this was M and I started at like 0th place. I will say, hey, I know I have already calculated M. Let me go to the left column. I'm starting from here, by the way, just to make sure that we are following from this end. You could do the same thing from this end, doesn't matter. Now you go to left, you will try to do the same. Like somewhere you will see, okay, here there is no water. So what will you do? You will do, okay, if there is no water, then there is no point going this way because I know that this side I will not get any water for sure, because the way it is given, like the values increases. So your only option is that you will come down. You will keep checking. You will keep like putting your toes in the water. As soon as you get it, you will say, hey, okay, I got something here. Okay, I have covered this area too. So you will keep adding that value, and you will keep going left when you don't get it. So what is happening at every instant, you are either going left or you are going down. So you are always making progress. Like you are always getting either like value to add, or if not, then you are not wasting any time. You are coming down. So in the worst case, you may have to visit like the entire diagonal, something like that. Maybe not. Sometimes you don't even have to do that. If everything is filled, then you will just traverse in this direction, and then you will have a O of M or O of N. But in the worst case, you can, of course, get O of M plus N. Does that make sense? Or any questions, feel free to ask.
Yeah. But in this case, if we know, let's say like you draw before, right? If M is much larger than N, then we would be go with the big O of N, right? Because we can select what direction we go based on the size of the row or columns?
Yeah, you can select that, but I think the input can be given in a way that is not going to help you a lot. Maybe like, currently we are seeing this way and the tank is like this, but you may have a totally different way to fill that tank. It all depends on how you want to make it. Maybe only this part is filled, right? Or maybe maybe this entire part is filled,
But
right?
we only travel maximum is only one side, right? Either row or column. So it doesn't matter how it feels. The runtime complexity would be the same, isn't
Yeah,
it?
yeah. Algorithmically, this is what you are getting. I'm saying like you, in general, you can't make things better than this, I guess. O of m plus n. Even if you go with like, okay, let me try to go for like, figure out some information ahead of time and then do like start from here rather than here. But that will change based on your input. So if you have like a lot of test cases, maybe like, your structure will not give you a better time complexity. This is the like, best you can get. Sometimes if it is a best case complexity could be O of m, sometimes O of n, but that again depends on the input. So you don't think about that, I would say. Does that make sense? I mean, it's just optimization. So don't think too much. Like you can try creating this like, kind of lane and you will figure that out. Or maybe, yeah, take some example. Anybody has any questions? Or can we move to the next problem? Or any question on this particular approach, feel free to ask now. Okay, looks like everybody understood it. Actually, there was a similar problem like this. So if somebody has solved that, it might have come to your mind already. All right, I'm erasing it. We will go to the next problem now. Oh, there is a chat. Let me check. Okay, I think it's old information. So the next problem is about what? Product of last k element. Okay. Okay, so this is a class design. You have to design a class product of numbers, okay, where you have to support two methods. Add numbers. Okay, we will go through this. So here your class will have product of numbers. You add these numbers like 3, 0, 2, 5, 3, and 4. So after that, maybe your storage, whatever you are using to store that information, may look like this. So that we know that first we added 3, then we added 0, then we added 2, then 5, then 4. And the other function which is here we have to implement is get product. And get product will give you this value to any value. This could be like anything up to k. And what you have to do, you have to product the last k numbers. So in this case, last two number will be 5 into 4. The reason being our storage was looking like this. So we took last two element and it was 20. Similarly, for the three numbers, it became like 2 into 5 into 4. For 4, it became 0 into 2 into 5 into 4, which is 0. And then 3 into 0 into 2 into 5 into 4, which will become 0 anyway. then we added 8, and then again we calculated last two, so 4 into 8 equal to 3. So it's a like simple problem. And then important thing to look at is that your number is 0 to 100 and k is equal to 40,000, and there will be at most 40,000 operations too. Okay, so now let's start this on the board. Has anyone solved it? Any approach you can talk about?
Yeah, I did. I think I didn't solve it. What I was thinking about it.
Okay, that's fine. So we'll talk about it. So let me take some examples just so that when we are talking about it, we know what we are discussing, right? So two operations, add and let's call it product. It will take k, and add, you are just appending values. So just for example, if product 2 we are looking at, let's call it P2. In this particular case, P2 will be 5 into 4, P3 will be 2 into 5 into 4, P4 will be things like 0 because we already calculated 0 into 2 into 5 into 4, things like that. Okay, so I'm looking for some ideas, or not only that, the important information was we have 40,000 operations, right? And 40,000 was something more. What was that? Let me check. There were two informations here which was useful. So K was also 40,000. Okay, good. So K could be 40,000 too. So how do you use that information when you get these values like 40,000 and 40,000 here? Like it should give you some idea already, like about how would we like to implement things. So here, if there are 40,000 operations and we are trying to do things like in a brute force way, for example, suppose like we have this 40,000 items in this queue or somewhere, and we want to do this for 40,000 times. One way is we will just iterate it, right? You continue multiplying. So one thing which may come to your mind, first of all, hey, we are multiplying these many items, will we get overflow? But luckily in the problem, it's already telling that you will not get overflow. So you should think about that for sure. But question is asking, okay, don't worry about it. So there is no overflow. But if we have n elements and we are like, multiplying each by one, so for each operation, we will go to these 40,000 items in the worst case, right? That's the max. So if we do 40,000 into 40,000, like 4 into 10 to the power 4 into 4 into 10 to the power 4, it's already 16 into 10 to the power 8. So it is already in 10 to the power 9 range. When you see anything 10 to the power n range, you know that ON is not going to work for sure. Even your log algorithms most likely will work up to something like 10 to the power 4 between 10 to the power 5. I don't know the exact numbers, but when you try to plot things like n log n, you will figure out like, looking at this information, what this problem will give you a hint which kind of approach we are looking towards. So we know that like
I have a question.
Yeah, go ahead.
Can you explain again how you get like 4 to the power 4 times 4 to the power 4?
Yeah. So they are asking you that they will run 40,000 operations, right?
Yes.
So this was number of operations. And they were also telling you that like K value, this could be maximum 40,000, right? So when they are telling you that these many operation can happen, you have to think like not one by one, like, in one run, they will try to do these many 40,000 operations. So, that if I, like, I'm thinking like, how would you calculate a multiplication of n numbers in a brute force way is you multiply one by one, right? So if you have 40,000 items and you multiply each one of that, you are doing 40,000 operations just for one, like multiplication, let me call it multiplication, just for one operation, right? But there are such 40,000 operations. So now you are actually consuming this much amount of operations plus complexity.
Got it.
Okay. So
So
what you,
yeah,
yeah, go ahead.
one way I was thinking that maybe as we are inserting the elements, okay, we can calculate the multiplication, like the product up until that time. Okay, so let's say like we inserted 3, the product is 3 up until that time. Okay, let's say like we don't have a 0, like we don't have zeros like in the array. Okay, let's say instead of the 0, let's say like we have 1.
Okay.
Okay. Then it will work, because let's say we have 3, so the first element is 3, then if the second element is 1, then 3 into 1, 3, then the third element is 2, then 3 into 1 into 2 is 6. Okay, so this way like we can manage the information.
Yeah.
But if there are zeros, then it will add additional complexity, because the whole product will be 0.
Yeah, in that case, I think we keep track of the the last index of 0. Then if the range is cover, that include index 0 there, then
So
the result
guys,
will be 0.
it's a good idea, and actually we will come to that. But so far, like, everybody knows that we are trying for things better than this, right? That is very clear, right? That we have to improve this thing, like, immensely. Like, I cannot afford to continue the multiplication one by one. I mean, intention is clear, right, to everyone, because I cannot make any optimization on number of operations. It is beyond my control. That is for sure, because the test case will run 40,000 operations. But what we are trying to do with, like, I can't see the name, but like, who suggested this idea of prefix product, is that try to optimize this one. And that's the only thing we can do. Like, there is no other way. So now our focus is how to multiply faster, how to get this result faster than, like, don't go to, like, all the previous elements and return the response, like, as soon as possible. So that is where this prefix product idea, just, like, used to come to your mind. If you have done some prefix sum approach, this will become natural to you, like it will come to you without you thinking about it. And we will deal with this zero case also. But does anyone has any doubt with prefix sum ideas, for like, just to make sure, because that solves a lot of problems. So I can give, like, 5 minutes overview of that, if you want to. Let me
Sure.
check. Should I do? Okay. Let's do that quickly. I can't see my whiteboard. Okay. So, okay, let's clear things, clear all drawings. So this prefix sum idea is, like, you are given a array anything, fill anything here. And you are asked, can you tell me sum between I to j? Could be 5, 6, 9, 2, 3. Of course, like brute force way would be, okay, between this and this, there are two elements, 9 plus 2. So you will just do things in a brute force way. 9 plus 2 equal to 11 makes sense. If this was a bigger one, then you will just do like, O of k operation, and you will figure that out. Now, if we want to make it faster, like the approach, it's very famous. Like what we can do is continue making a sum of like, previous elements. So 5 is 6. You can have a 0 for like an implementation purpose, but that's beyond the scope. Just think like this. So 5 plus 6 is equal to 11. So we'll fill 11 here. Next is, this was 9. So this was 20. Next is 2. So 20 plus 2 is 22. And then 25. So suppose you created this in the beginning itself. And then there are a lot of queries. Now they are asking you, hey, I will ask this question you 40,000 times or 100,000 times. What we can do, like, when we have to solve, like, what was the sum between, say, here, our first problem was between this and this, 9 and 2, right? We have one extra element, so that's why. So looking at the sum, you can figure out, hey, 22 and 11. Since I know the sum from here to here, and I also know the sum from here to here, all I have to do is subtract these two guys, right? If you know sum from here to here, and you know from here to here, for this area, all you have to do is subtract these two things, sorry, here. So 22 minus 11 equal to 11. Same like with these three things, you will go add these things. You will only check this value and this value, and we'll say, hey, the sum is 25 minus 11. So 14 is the sum. If you calculate manually, then you will say 3 plus 2 plus 9 is 14. So your time complexity, every time you are only looking at two elements. So you have reduced this to O of 1, right?
Right.
So that is the basic prefix something. It will be used a lot in dynamic programming, because there you want to optimize like your calls when you are making too many calls. So in a lot of problems you will need this thing. So it's good to learn this as a technique. So that was a general overview. Now somebody already figured out, thought about it. So in this particular case, instead of prefix sum, we are trying to get prefix product. And this can work because we are also given that there is no overflow. So because multiplication in general is very it grows faster than that. So we should think about overflow, and it's not a problem here. But the problem was that there is a 0. So let's we'll go to that example and we'll try to figure that out, what to do. 30254 was our example. So 254, what was proposed that if somebody asks me last two elements, then 4 into 5 is my answer. If last three elements, then okay, we are doing this 2 into 4 into 5. So 2 into, actually, let me change the order, 2 into 5 into 4, this way. So, but the problem was, what if there is a 0? When there is a 0, then this will become 0 into 2 into 5 into 4. So here k was, for example, 4. So our answer was 0. Now, will it change if I say k equal to 5? because as soon as you get a 0, no matter what you do, it will make everything here. It doesn't matter what you have. This got multiplied by a 0. That means, like, it's a 0. So that is the special information here, because that will turn things in 0. So you can use that information in favor of this implementation in a way. Sorry, there is a chat. What is the problem? I did using square root decomposition, dividing the entire range into buckets of 200. Okay, and then get the pre-computed products from the range for any set of indexes that do not cover the entire bucket. We manually multiply by each element in actual list instead of pre-computed bucket. Okay. So let's see, if we have time, we can talk about that. We'll finish this and then we can talk about it. So what should we do? Okay, so idea was, like, suppose 0 was not there. Let's be just have happy case. So the problem says, hey, there is no 0. So suppose this was 5. So using the same approach, what is being told, like prefix sum approach, we will have prefix product. So what we will have, we will calculate something like M, which will have, suppose, 3 into 5 into 2 into 5 into 4. Okay, we have already calculated everything here. Now, if somebody asks me, okay, give me the product of last 2 elements. So what I have to do is, if you have full product and if you divide it by 3 into 5 into 2, you will get this value which you are interested in, right?
Yep.
So all you have to keep is this, like we had this array of sum. You have to have array of product which have products from beginning till the end, and then we can figure that out. Okay, so the case is similar without 0, but with 0 what will happen, as we saw, that if there is a 0, if you go towards left, it will make everything 0. So anyone can first suggest something before I talk about it. How would you handle 0 using this approach?
Yeah, so my was thinking keep the index of the last 0, right? So once we see 0, we don't need to do the pre-sum, because whatever after 0 will be 0, right? So now let's say, from our current index, and they want to ask for the range of k, and if k is covered the last index 0, then we know the product will be 0.
That should work, I think, right? So yeah, what you are saying, that if the last I was, like, I know that I equal to, in this particular case, let's call it 1, or 2, let's call it 2. I am not using 0 based, and there are 5 elements total, n equal to 5, and your k was for example 4. So based on these 3 things, you can figure that out. Hey, there is a 0 which will find this guy, right? Because 4 plus 2 is greater than, actually 4 is the, yeah. So we start from here, we go towards left 4 steps. I will reach on an index which has already a 0 in between. So I can say, okay, just return 0, right?
Right.
Okay.
But
Yeah,
we
that's,
still need to keep the pre-sum, right? Because in case, let's say the last 2, then it does not cover 0, we still need to return 20 in here. In case k equal 2.
Oh yeah. So yes, we are going to store it. What was the question?
So I believe like in this case, when we are calculating a product array, then like prefix product array, then what we will do, we will start with 3. Okay, we will have 3 in the array. As soon as like we reach 0, we put 0, and from that point on, like we reset. Then then again we get another 2. It should be 2, then 2 into 5, 10, and then into 4, 40.
Right.
And also keep the index of last 0 as mentioned.
Yeah, I think this approach is even smarter because here you are saving space for sure. You are resetting. I think you will not even need to store that, because now you started with 3, for example.
3, and then second will be as soon as we reach 0, like it will be 0.
So
and then
you cleaned it up, right? You said nothing is there.
no, like just like keep that array.
Okay.
And then have 2.
Okay.
Because once we found a 0, we reset our calculation, multiplication from there.
Yeah, your multiplication became 1, right? Because
and then 10 after 2, 10, and then 40.
10 and then 40.
Yeah.
Oh, this is your multiplication table. Okay. Yeah. So okay.
Prefix product.
Prefix product. So you have it. So you have 3, 0, 2, 10, 40, right?
Yeah. So let's say like.
So one idea is, if suppose I just reset it, I just cleaned it up for the time being. Let's think. Yes. I also know the size of this, right? If somebody asks me anything where k is up to 3, I know that I have the product. If somebody asks for 4, then I can say, hey, like maybe it was not useful for me, because this was not useful, then that makes this guy also unuseful, right? Because that will also be 0.
That makes sense.
So yeah, you can just erase this thing. No need of it.
And at any given point, let's say if I'm asked like product of last 2, okay, then I take the last one, 40.
Okay.
And then divide it by the 2.
Yeah, 40 by 2. Yeah, that's the same idea. And yeah, that should work.
Wait, can divide by 2? Let me see.
So he got the multiplication till the end.
Okay.
And he also got the multiplication till just 1 before the range. So you want to continue the multiplication for these two guys, right? These two guys means like, in the above picture, 5 to 4. Let's see here.
Yeah, right. Yeah.
Right. So what you will do, you will get everything till the end and things before this, right? So for 2, that value was 2. And for total, that was 40. Same idea. You just did it and you will get the answer.
So let me try. Because when we keep adding number, we increment the index. Similar, we increment the index, right? But right now we don't keep track of the cumulative index.
Yeah, so now we don't keep any info of 0, because when 0 comes, you are resetting things. Why you are resetting? Because you know that if I got a 0, like, at any index, like here, you got a 0 here. And suppose there was no 0 in this area. All these are good for us. Anything from here till the end, I know that it will be 0 no matter what, because our multiplication starts in this direction. It cannot exclude these guys, right? But anything after this has to become 0 because of this guy. So in this approach, we see like as soon as we see a 0, we are saying, okay, just reset our storage itself, like the cumulative sum product array. And based on the size, I know like if my size was like, here 3 and somebody asked me for 5, like, I know, hey, my size is only 3. So I know the last 3 guys were good. And I'm pretty sure there was one guy who had a 0 after me, like, in this direction. So it must be 0. So don't even deal with it. Sounds good?
Yeah. It's
Okay.
even better. Yeah.
All right. So I think Puneet was trying to suggest some approach, and there was a lot of chats. Can someone talk about it? Puneet, do you want to talk about it? I think this is clear to everyone, right? Okay.
Right. Yeah.
Oh, Puneet still has his, okay, throat thing. Okay, this is a very useful information, and I would suggest, can you paste this in our lead code practice chat? I will have to revisit it. That would be great. Okay, great. Thank you. So that was a good question, a nice answer, and hope that it helps you to solve other prefix, sum, or product related problems. At least think about it. So we'll go
So
to the next.
in this problem, the value in the question, the value is always positive, right?
Yeah, I think that was the case.
Would that the answer would be would we still use the same approach if the value could be negative?
So I think that may still work as long as you don't have a like overflow thing, because if you have two negatives, they will cancel each other. If you have one negative, then division by from a positive to negative also will give you the negative. So it should work.
Okay.
Yeah, I think so. But also like when if you are storing zeros somewhere and trying to divide in your approach, make sure that don't divide by 0. Like that will give you some runtime error for whatever reason if you have to.
If this case, in this case, let's say the problem say, it does not take care of overflow, and they give us a mod number, would that still work?
No, it won't, because mod is, what will you get? Like it will not give you the actual product. If the problem is saying that if it overflows and then you mod it, then it may work actually. Yeah, it may work. Yeah, because as soon as you start to cross this, there will be something value like 1E9 plus 7. Normally that is the thing. Then you will change this value.
Like modded by what?
Yeah, so they will probably give you a big prime number.
Some big prime number, or let's say maybe we can assume like some number as 100 or 1000 or something like that, and then use that.
Yeah, so
But there should be some constraint.
Yeah, okay, let's clear this one. So suppose 2, 3, 5, and your big mod number is, what do you want, like 100? Normally it's prime, but calculation will be tough actually. But the thing is, once you cross this, 4, 2, 3, 5, make it 10. So 2 into 3 into 5 into 10 become 300. So how would we change it? We will change it to divide by 100. It will become 3, right? And then if we have to calculate that, actually it may not work, because I cannot use that information to, yeah, it will not work. because now if I have to just figure this thing out, this guy didn't overflow. So it is like, oh, sorry, not this one, just this one, 10 into 5. This didn't overflow. So earlier what I was trying to do, 2 into 3 into 5 into 10, and then I was trying to divide it by 2 into 3. Now what I said, this has become actually 3, right? So if I will have this one and this value 2 into 3, it will give me something totally like, yeah, useless thing, 1 by 2. So it will not work. Is that okay? Like, try to do it, and then instead of 100 use some prime number. Normally they use this number in most of the problem, and then you will figure that out. It will not work. The reason is like, now this is not useful for us if we mod it. So most likely won't. Can you go to the next one?
Yes.
Okay. So we'll take, what was the next one? Let me stop share. Okay, so, okay, maximum number of events that can be attended. So given an array of events where events I equal to start day, end day, every event I starts at start day and ends at end day, you can attend an event at any day where that day is between these 2 days. Okay, and also you can only attend one event at a time. Return the maximum number of events you can attend. Okay, so this is the start. So this event is running from day 1 till day 2. Second one is running from day 2 till day 3. And third one is running from day 3 till day 4. So how I can attend? I can attend the first event on first day, second event on second day, third on third day. So the maximum I can attend is like 3 events. And what is the bound is that there will be 10 to the power 5 events, and we have start and end date, and this start and end date will also be up to 10 to the power 5 days. So 10 to the power 5 events are there, and also days are like 10 to the power 5. Okay, so that just gives me an idea that something like n log n may work. Not like, n square will not work for sure, but we will talk about it. Yeah, so let's share again. Has anyone solved it? I will just write the example. I will leave you for 1 or 2 minutes and then please discuss. So 1, 2, 2, 3, and 3, 4. So something like this is the event. So this is my first day. I can do this thing. First day. Second day, I will do event number 2. Third day, okay, this is my third day. I can do event number 3. And there are 10 to the power 5 events, and I have 10 to the power 5 days. Okay. Please discuss and give me 2 minutes and then I will be back.
Mhm.
Okay, anybody has any ideas or solved it earlier or looking at this interval problem, there is anything which comes to mind like intuition wise?
It looked like this is let's say if the intervals not overlap, then we get easy, we just pick that one, right? But let's say let's look at only two interval we have.
Oh yeah, sure.
And then for greedy, I think we just pick the first day of the how to say that, the smaller interval.
Somebody said greedy, right? You said greedy, right? So I like that. Like when you see interval problems based on the experience, it comes to my mind too. Not necessarily it will always work, but it's good to think like, hey, there are intervals, and there are two things when you have interval. One is start, one is end, right? So normally what you do, if it's not already sorted, you try to sort it, and based on that you make some decisions, right? So when you make some temporary decisions which may lead you to a best result, that's a greedy approach. So in this particular case, how we can apply that, we will look into it. But yeah, suppose this was your interval, forget about that, then what will you do? Like everything is starting from first day. Like you have these many events, e1, e2, say e3, e4, and you have, maybe you have, so okay, also days, so this goes till day 1, this goes till day 2, this goes till day 1, like I'm starting with 0 for example, and this goes till day 3. So how many maximum event you think you can do?
Three.
You can do 3. Why you can't do 4?
Because I can, let me see, because I can only do one event at one day.
That's right.
So we have only 3 days. So in this case, if I select event 1, then I cannot select event 3.
Mm-hmm. That's right. So okay, so you have to make a choice that either you want to go to event 1 or event 3 for E2. And also not only that, actually, can you do event 2 on first date? With this, I liked your idea. So suppose you choose that, hey, I will do E1, E2, and E4. First day, second day, and third day, right? So now the question is, if I want to do event 2 on first day, can I, if I do that, can I maximize the number of events I attend?
No, because if select event 2 on the first day, the maximum will be only 2.
Right.
Because it already overlap with E1 and E3.
Mm-hmm. So if I go and do E1, if I have to choose between E1 and E3, I can choose anyone, doesn't make difference because I can only do one of those. Both interval will finish together, so no problem. But when I have to make a choice between E1 and E2, and then I would always try to prefer E1. The only reason is that I can still do E2 after E1, but not the other way. If I do E2 on second day, E1 is already finished for me, right?
Right.
So this end time, you have been given 2 interval, is also playing a role to make a decision. And the start time is also playing a role so that you know that on that particular day, what options you have, right?
Yeah.
So, right. So as a person now think about, like, actually this is a problem exactly coined like that. So, okay, I started my day. I want to go to event today. Today is the first day. And then there could be many events on today. So what I will do, I will try to look at, hey, which events are available for today, which are starting at least from today, right? So in this particular case, since everything starts from day, I will look at all these events. Okay, I can either do E1, E2, E3, E4. Okay, so now what event I would choose? My only class is between E1 and E3 mostly, right? Because E2 and E4 have more life, so I can do that later. So we'll just choose whichever is ending faster, right?
Right.
So we will just do one event today, and this was just like everything was going like that. But in other case, when I am going to, suppose now in this example, I could have done this one, and when next day started, I will choose, okay, what are the events today? Let's make it interesting. Suppose you have one more event which is like that. You had one more event which is like that, things like that. So after I make first day's decision, this third day, when I open my notebook, I would like to check, okay, what events are starting today, and also, I want the one which is ending like faster, I would like to do that. That's the greedy thing here. And also, when suppose I am here, I have done, suppose, I chose this one, I finished this one, I finished this one. Now when I am adding this one, this new event which came today, this event doesn't make any sense for me, right? Because it has expired already. This event has also expired. Suppose there were 3 such events. I did one, but suppose there were many and I added it to my notebook. Hey, I want to do this. But if the day is already passed, I cannot do this event no matter what I do, right? So on that particular day, you also have to go and delete all the events which already passed. And then among the ones which are still going on, you will choose which one is ending like, now, as soon as possible, I will just choose that. So is the approach clear? Like, the context why I'm trying to do that. Once we have why covered, then we can talk about how we will do it. But is the intention clear?
Yeah. But Roger, one thing, like it will fail if our first even was 0 to 2. Will it not fail? Like we are picking even first and instead of E3.
Even first instead of E3. So actually, sorry, this is this is starting at the same time. I can't draw that well. This
Yeah.
is
No,
this is at
if even is 0 to 2 and we
yeah.
have 4 days. So ideally we should choose E3, right? First.
No, we have 3 days. Here,
Okay.
see,
Okay.
this
Got
is
it.
yeah.
Yeah. Then different example. I will
Yeah,
take.
yeah,
Go ahead.
it's 3. So otherwise, like why we are like, looking at the, like when the event is ending, we want to do the event which is ending now, because if I finish that one, I still have chance to do things which I can do in future, right?
Yeah.
Okay. So if that is clear, then we can talk about how part. So what is important for us? Like end time on any particular day, when I check my notebook, I have to look at, okay, I have already added new events which I can do. Also, I have already, so I added events. Let me write added new events starting from today. That is one thing I can do. Second, delete old events which I can't do or expired. And now the final today, when I'm going to choose something which I can do, I will check my notebook. Okay, among the say 10 events, which one I should choose? Whichever has the least end time, like whichever is ending soon, right?
Yep.
Choose event ending sooner. So which data structure can help you to do these things?
I think it's a priority queue.
Okay.
Yeah, the priority queue, we can find the earliest ending time.
Mm-hmm.
Yeah, the first step is to sort the events by using the start time. And when we start an event, we push that event ending time to the priority queue.
Sure.
And then if in the priority queue top, that means the earliest ending time is early than current time. We just pump it out because we start to join the current event.
Okay. So you sorted in the beginning by start time, and in the priority queue, you are storing things based on end time, and priority could be of 2 ways, like max or min. So you care about min, right?
Yeah.
Min heap. Let's call it min heap implementation. And every day when you come here, as we wrote in the previous things, we start adding events starting from today on that particular day. So we'll add new events, delete old events or expire, and then choose one, right?
Yes.
And
So
then choose one.
on
Yeah.
are we looking through each day, like day 1, day 2, day 3? Or we look through the sorted array?
For each
That's the one question. The second question is like, you know, if we sorted the array, if the start time of 2 events are the same, then are we're gonna sort by the end time?
Sorry, I didn't get your question.
When you
First
sort,
question I got that for each day we are doing. This is currently proposed.
okay, so that's, yeah, so that's each day you do, you know, the number of day for the event, so look through each day. Okay, and the second one is when we're sorting. The first step when we're sorting, and 2 events have the same start time. Then are we also sort on the end time?
That you will not need, because when we are adding to the priority queue, we are already doing that. So you don't have to sort that way. Like, it's not, with this approach, we will have that information if we put in the priority queue.
I think that also will fail because let's say I have one event which is start from day 1 and ending at day 9. But there is another event which is start at day 2 and ending at day 3. So my day 2, day 3 event will take preference over 1 to 9 one if I have different other events also, right?
Yeah, that is if you don't use this approach at all, right?
Yeah. No,
Yeah.
so what he was saying, like if we already shorted with the start time,
okay.
If again short this array, if the start time is same, sort it with the end time also now. The same array instead of using priority queue. So I think then this, because of these kind of example, when I have a start time from 1 to 9, it might end up running later. I will be attending that event later after an event which is something like starting at 2 and ending at 3. That kind of
but in that case, the start time are not the same.
Yeah.
So the sorting would be normal.
No, so I can have one event which is 1 to 2, then 1 to 9, and then 2 to 3. So I will be attending 1 to 2 first, then 2 to 3 second, and 1 to 9 at the last. Right?
Yeah, I agree. So I think maybe the priority queue to put to the ending time to the priority queue, that step is in the for each day loop. After ending a new event, and then put that new event ending time to the priority queue.
Yeah, so single array can't solve this, I think, which he was telling that if we sort this array again with the end time, I think then we will not be able to. We anyway need some other data structure to store the end time. That's what I think.
Yeah, there is some example Puneet gave. Can someone talk? Like, read that. I can write it here.
Yeah, just a second.
Let me clear things up. So we have one approach working. Okay, we will talk a little bit more maybe.
Yeah, he gave 1 5.
1 5.
1 5. 3 times 1 5.
Oh, okay.
And 2 3 2 3. 2 times 2 3.
2 3 2 3. So okay. So suppose 1 5 1 5 1 5 2 3 2 3 2 3. Okay. First day you can do 1, right? This one. Let's do this one. So 2 3. Let's do this guy second day. Let's do this guy third day, right? So first day, second day, third day I did this one, and then I still have 2 more days to go, so I can do maybe this one on 4th day and this one on 5th day. So ideally we should be able to do all of this.
All 5, yeah.
So now what we are talking about, if it was like, we were sorting by end time as well. So how we, okay, first day we will do, so Yeah, so what he's saying that, okay, you will use your first day to do this, second day to do this, third day to do this, and
Yeah.
that's it, because these guys are not even possible.
Yeah.
So, yeah, that's a good example. Thanks, Puneet. Okay, and does anybody, because somebody was talking about it a long time back. So in priority queue, suppose you know things ahead of time, like, what is the time complexity to build priority queue? Actually, in the next problem, we will already talk about it, I guess, if I remember.
Log n.
That we will talk maybe in next one. Yeah, let's discuss that, because we have already spent quite some time. That's the last problem. We'll do that. And we will talk about it also. Stop sharing. What was the last problem? Construct target array with multiple sums. Okay. So last problem for today is you are given target 935. You start with always with something like 111. It's not just 3 elements. It could be up to 50,000 elements here. But the first, you always starts with 11111, and then you want to reach a particular target. And what you can do at each level, that you sum the current array, and then you can choose any index, and you can change that particular index with the value of whatever sum you got. So sum for this is 3. So what I will do, like for example, I made this 131. I just changed this middle value here. Now the new sum has become 5, and I will do the same here. I changed this last guy. And then we again added this value, 5 plus 3 plus 1 is 9. And then we change this first value. So starting from 111, we are reaching 935. And the thing is that question is, can we reach or not? Not the steps, but the question is just, can we reach or not? And bound is that each target value is up to 10 to the power n, and target length is 50,000 almost. Okay, so let me try to explain the problem here one more time, and then I will let you think for some time, and then we'll discuss the approaches. Okay, so the question was, we wanted to reach 935, and we always start with 111. These 3 values are just for example, but it could be a bigger array. So what you do, you first sum it up. 111 is 3, and then you can change it. Maybe in this first step, you can make it 131. Now you will again sum it up. So 3 plus 1 plus 1 is 5. I can choose any value. So let me choose 1, 3, 5. And again, the sum is 5 plus 3 plus 9. So let's make the first guy 935. So we were able to reach from here to here, this way, finally to 935. So you have to return true. Each value is up to 10 to the power n. So this could be up to 10 to the power n, each of these. And number of elements in this array could be, I think, 50K. That's the bound. So let's first think about this. If you have already solved, then just wait for others to give like 1 or 2 minutes, and then we'll talk about it.
I have not solved it, but I will share my thinking. This is the sum, right? So this seemed to me, that appeared to me, this is the monotonically increase. So for the given array, I will look at the smallest, the minimum value, and then how I can reach that value first.
Okay. So somebody, like when you looked at this, like intuition wise, did anybody think about BFS? I'm just curious.
No.
Okay.
How does this one link to BFS?
It won't solve the problem. I was just trying to develop an intuition, like it's possible, but not in this particular problem, but intuition wise. So we will see.
Not exactly BFS. I thought of, creating 3 paths out of it and trying out. But not able to think of like BFS is what I'm doing actually.
Yeah, I mean, like I will say I meant the same.
Yeah.
Like, by saying BFS, like if you think in that direction. Yeah, Punita, change of stress it can be graph. Okay, we will talk about that actually. So we will see why, what I thought to begin with. 1 1 1, right? What can we do? I know the sum of this is 3, right?
Yeah.
So one way is like, okay, I can make any guy 3, right? So I can either make 3 1 1. I can make this guy 1 3 1, and then I can make this one 1 1 3, right?
Yeah.
And then everybody will have their own children's, but let's say I'm working with on the in times. We have less time, so let me work on this one. So now the sum is 5, right? So 5 3 1. Sound good?
Yeah.
I can do this. I can do again
151.
151. And again 135.
Yeah.
Okay. And then let's start from here. So 935. I can't write that well on this, but anyway. 1 9 5 and 1 3 9. Okay. And similarly, these guys will have their own 3. These guys will have their own 3 things, and it will keep going on. Something like this. So now can somebody think it's like a graph, right? At least mentally model it like a graph.
Yeah.
Okay. If it keep growing like that, then when would we know when to stop? Let's say we go down like the depth first search, like one branches.
Yeah, we'll talk about it. I mean, like you have to optimize. You have to like, think that, hey, the value which I am searching at a particular index, for example, like suppose I am looking for this 9 on the first index. I can use that like, hey, like if something is growing more than like, I'm at 19, I don't know what is this. But if it is like, more than 9 and all numbers are positive, maybe I should not further even go. You can do that kind of optimization, right?
Yeah.
So you can do that. So now the problem is, this is 935, right? We want to reach this place. This is our starting point. So one way is, okay, try all the possible things. keep doing that, and someday we will find this exact match, right? So you do the queue approach, you start adding values in the queue, every level you try to evaluate, these are different levels of the graph, and that will work in theory for sure. But if you look at it, the branching factor, it's like every time your branching factor is increasing immensely. Like it's not just three was in this example, but if there were n elements, then you started with 1, then you have n, right? And then what will happen? It will grow again, like, each n will produce n. So maybe n square.
Mm-hmm.
So see, like, every level it is growing tremendously. So given the time constraint, like, we cannot solve it for sure. So now the question is, this guy is, somebody is starting from here and trying to reach here. The other approach, we have talked about it once. So does anybody remember? I will see, like, somebody thinks about it.
We can do two search at the same time. I mean, you have a target. We have a target. We start from the target, and we also start from the beginning at the same time and try to meet in the middle.
That's you have too many approaches, I like that. But yes, in the same direction, but probably just target search is fine, right? So what we need to improve things is, like, suppose this is a, like, let's call it, is he a grandparent or something? What is the, let me check the message. We have a message. Can somebody read for me? Or no message? Okay, I don't know. I will ignore. So let's start. So suppose this guy is the grandparent. This grandparent wants to reach this guy, but the way he will reach is he only can find his children, right? And he can do that after applying this rule. He doesn't know which children will lead him to the actually the to this guy, the guy he is searching. But if this grandchildren tries to go to his grandparent, if he knows who his father is, right, or his parent is, he can always figure that out. Suppose we will see how he can always figure out. If he knows his father, then he will in one step will ask his father, hey, where did I come from? Okay, then he will go to his father. He will go to his father. And if you look at it, in one, and at least in this example, 2, 3 step, he can reach to his destination, right?
Yes.
So now the question boils down to, can you derive a parent based on its own value? Right? If I have that information, I am going to have a very much better complexity, like, right? So from 935, can we derive that 935, like, let me make some space on the board. So 935, where did he come from? You know that we always add values in the previous step and we change the max value at certain index. So we know that definitely this guy was changed in my previous step, right? Because, so I know that, okay, 3,5 is fixed, but this value was something else. And what was that value? that if we can determine that, then we will know that, hey, I know who my parent was. Right?
Right.
Yep.
So, and also every step, suppose this was X, I don't know what it was. Let's say this was X. So what we do X plus 3 plus 5, whatever is that value, I changed it here, right?
Yeah.
So if I know X plus 3 plus 5 was 9, can I say what X was?
Yeah.
It was 1, right?
Yeah.
So it is feasible to figure that out without doing too much. If I know the sum, see, this was just like, 3 elements, but if there were many elements, then you will have this kind of equation that X plus sum of all other numbers equal to whatever was this value, right? Right?
Yeah.
Then I can figure out this, and based on this value, I know my previous state, and then I can keep checking my parent, and then I can lead to the solution.
In this case, the children only have exactly one parent, right? It look like it, but I cannot prove.
What is the question? Can you repeat?
A node, a given node only have a single parent. Is that the right statement?
I think that is true. I haven't drawn examples, but I think that is true.
So in this approach, we are just checking if it's able to reach to 111 at the end, right?
Yeah. Can we reach to 111? That's a true false question.
Got it. And we are always picking the maximum of all the elements.
Yeah, because that's how we change the values, right? So we added and then we just change that value. So the sum will be always biggest.
Yep.
Positive numbers.
Yeah.
So we can do that. So that's how you will approach, like at least, based on that thinking.
Yeah, makes sense. Can you take another example where it was failing? We're not able to reach it. Target was not true. I was just trying to think of what it will be some negative number come because we are trying to decrease it, and I think it will fail. Yeah, I think it makes sense.
Yes, suppose you, because in this problem they have given you like start from 935. What if somebody gave you 1035?
Yeah.
So what will happen when you will go using this way?
Yeah.
You will go to maybe from 1035 you will go to 235.
Yeah.
From 235 now where can you go? 5 is the biggest one, right? So this guy changed.
Zero.
You already reached 0, right?
Yeah.
Somewhere. So 230, and then after that, if anything becomes 0, like, hey, he's going to get smaller only because we are going up.
Yeah.
So you better you can try, but maybe you will go negative, and then you will say this doesn't.
Yeah.
It's not possible.
Yeah, I can break here itself, like if any of the element is less than 1. Got it.
Yeah. So that's the rough idea.
Yeah,
and
I got
then,
it.
Then there are a couple of optimizations on top of it, which is like, otherwise it was still failing. Was suppose, okay, let me, so for some reason today eraser is not working for me. I can't just erase. Oh, luckily now I can. Like, suppose you have some value where you can take, like here we are taking one step at a time, right? If you think, but suppose like there was a tree like this, like this, like going forever. Suppose there was only 2 value, like, I saw somewhere, like, there was a test case where you have like 10,000 or 100,001. So what is happening? We are always changing this value.
Yeah.
Right. And we are taking one step at a time.
Yeah.
So what that test case is making you that trying to slow you down, because now you are going up one step at a time. But if I know that I can, reach higher jump, I can do a higher jump here itself. Because see, there is a huge difference.
Yeah.
It's not just like 2 3 5. It's not like that. If you reduce 5, someone else became the biggest one.
Yeah.
So if you can do that, then you will immediately make a jump from here to here, for example. So that one jump can give you a faster time complexity.
Yeah, but how are we deciding that this use case is to jump more? Like by seeing it, it looks good, but can this type of jump use case comes when we have more than size 2?
So if you think like what we are doing, we are subtracting something again and again, right? In this way. So when you subtracting things multiple times, what does that basically means? You are dividing. Similar, like if you are adding things multiple times, it means you are multiplying, right?
Yes. Yes.
So 3, 3, 3, 3, 5 times.
Yeah.
You can reduce that to 3 into 5.
Yeah.
Same with like 15 minus 3 minus 3. You can just do 15 minus 3 into 4, like you divide by it. So you will do that and using you can do modulo, like this operation.
Yeah.
That's what you can do. And then you can take a big jump there right away. That will help you to achieve a better time complexity. And since you are always caring about this thing, biggest number, you are again going to have a priority queue here, right? Because that is where you are starting your jumps from. Make sense?
Yeah.
So you have a priority queue. Also, we today talked about cumulative sum, right? So last time we were talking about when we were trying to find the parent, a couple of minutes ago. So that parent was total sum minus, if you just do total sum minus whatever is the max, you can calculate everything other than the max guy. Like for this example, you have 935. I know the total sum is, in this case, 5 plus 3 is 17. Suppose I keep count of current sum, like total sum, and I know max, then I don't have to iterate on this, for 3, 5, there could be more things. I can directly say, hey, anything 17 minus 9 is the sum of this entire thing in one operation, right? So that approach which we talked about, cumulative sum, is again happening here to optimize your time even more. So anyone has any questions on this, or try solving this problem? And I don't know who is still online. I know it's pretty late, so feel free to leave this. But yeah, I think I just want to make sure that you know the approach, so that next time when you see this problem, you can try a couple of options.
How would you, how is the runtime complexity of this problem? How we calculate it?
Yeah, that's a good question. So we have a heap here, right? Again, priority queue. And depends on what we put in the priority queue. So in the priority queue, we are definitely adding all the elements because I know that that element could become the max element at one point of time, possibly, right? So now that was my previous time I was talking about what is the runtime complexity of adding n elements in a priority queue. I mean, that is one part of this problem. So you put n elements in a priority queue. Okay, let me clear it now. We have done with this approach. So you have a priority queue, you put n elements in this. So there, like, we have talked about it a little bit, not in detail, whether it is n log n or O of n.
Log n is for every insertion, and we are inserting n items, so it will be n log n, I believe.
Okay. Anybody has any other ideas or has heard about this to build, like, heap? Okay, so probably not. I will discuss it, after we finish the recording because we are running, like, out of time. But make sure, read about it, and I will try to explain a little bit after the session. Build heap, time complexity.
Yep.
So there are some papers and there are some, like, justification why it is O of n and not O of n log n. Still, if you are using Java priority queue,
Yep.
this is what you will get. I think in C++, they have a constructor which uses that particular way to make it still O of n. I mean, that is my idea. I am not, like, I don't use C++ that much, but I think they have a constructor which can do this, but not Java.
So the Heapify is not even going on in there. That's what I think. Because every step we have to update the location of the top. That's why it is taking log n.
We will talk about the details just after the session. Like,
cool, you can stop recording.
Yeah. But yeah, so that was one part. Like, I will say I will go with O of n log n still. And then there was another thing where you were jumping things like this, right? You are reaching like this. So you are making some jumps here and here. So that will take another, depending on the height, it may take, so definitely log n is one thing. Plus these jumps are reducing it. So there could be another log factor, log of whatever was the max value, like, but it is not that straightforward. So let's call it log max, because we started jump from here, we came here, then we are making another jump. These things are all log in itself. So it's not like we are going like this was log n, but here we are doing this kind of jump. So there will be log of max value into log n. Yeah, it's like exactly like when you figure out greatest common divisor, it uses the similar kind of things where value of A and B changes. So you can look at time complexity for, like, GCD, greatest common divisor. Look at this time complexity, and we are kind of doing the similar thing again and again here. So that's it. All right, I will stop the recording and then I will stay, like, we'll talk about this build heap if somebody's interested a little bit, talk about that.
Sure.
Okay, so let's stop sharing. Stop recording.